So, welcome back. Um, I said around same time in Friday, so I followed up. Surprisingly enough, welcome back officially. And today I have somewhat of a presentation for you. Um, I am officially going to introduce you to the microscope because last time I realized that most people do not have um, connections or do not have experience with microscopes. So yeah. Um, so if you will, let's begin. I've been fairly excited for this one because I love this. Let me change the angle so okay you can see a bit better. So this contraption, it's one of the most amazing of my favorite gadgets. I hope that my frame rate is good enough because what I'm seeing in my preview is shit, but for now, that's all I have. So, you're gonna have to deal with it, and I'm sorry about that. But hashtag sorry not sorry, but whatever. So this is my microscope. It's a Bresser model. The company. It's a company that makes fairly cheap but also professional grade microscopes for lab use and all and what not basically. And well, it served me quite well in the past 4 years actually. It has fairly good optical quality. It's decent. So yeah. So, first of all, the most important part of the microscope is the lenses, the optics. So, let me change the camera angle so you can see a bit better. There we go. I should be in the frame also, I guess. So yeah, this beast has a rotating drum essentially, which contains 4 slots for lenses. Now these lenses are interchangeable. Like you can, let me unscrew this one and show you. You can unscrew them and yep. Let's zoom in a bit so you can see it better. Come on, camera, focus, please. It didn't. Come on. Yeah. So, this is my 40 times lens, magnification lens. And it's a basic quality one, but it's decent for what it does. Oh, we closed it again. So, yeah. And yeah, so the lenses can be screwed and unscrewed, and you can change the order depending on what you need. You can get new lenses, better lenses, and put them into the older body, on the previous body, and so on. So, the second part of the optics is this part. This is the head of the microscope, and it contains 2 things: a mirror and a beam splitter. Now, the beam splitter is inside here and you cannot see it, unfortunately. I am going to clean this up at some point and I'm going to do it probably live. So you should maybe, if you wanna watch that, you should follow. So yeah, the head of the microscope, generally most microscopes, especially beginner microscopes, have only two slots for lenses, for eyepieces. The eyepieces are used to essentially reform the image that the objective lenses have created. So light comes off from the source, goes through the condenser. I will talk about the condenser in a bit, and through the sample, through the slide, and into the objective. The objective then forms the image, okay, and it travels through here into the beam splitter at the head of the microscope. The beam splitter in these microscopes splits the beam into three parts. The first part is the eyepieces, okay, and like it's a beam that gets split into two, so you get two identical images, essentially, one for each eye. It's way more comfortable. Some people though prefer just observing with one eye, because if you do not configure them properly, it can make you really, really dizzy. Or if you're not experienced enough, because it needs some tweaking, you know. And inside here, there's a prism that splits the beam into two, and mirrors on these sides that redirect the light into the eyepieces, and from the eyepieces, obviously, into your eyes. I truly hope the stream is watchable right now. Okay, so the eyepieces can be exchanged also. It's a fairly versatile system. Well, most microscopes are. And they come at different magnifications, different focusing distances, essentially. You place your eye at a different distance depending on the lens. Some lenses are configured for people in glasses, because if you're especially in a lab and you're working and you need to watch your data or make some drawings or look at the computer or whatever, and you wear glasses of any kind, you need to be able to see at the same time both through the eyepiece and normally with your glasses, and that needs a bigger focusing distance. So yeah. Also, one other thing most microscopes have is essentially an adjuster for different myopic or for different eye conditions. For example, if you have different myopia, I'm not sure what short-sightedness, I guess. I'm not exactly sure what the translation is in English, but so yeah, if one eye has a different myopia than the other one, you can adjust it by rotating, and you'll be able to watch the exact same image with both of your eyes. And that's really important, as I said before, because it's very, very easy to get dizzy if you do not adjust it correctly. The eyepieces obviously they can be adjusted for the distance between your eyes. This is larger, this is smaller. Mine is they're quite far apart actually. So yeah, I have configured them perfectly for me, but well, most of my friends that have looked through the microscope need to close it for a fair amount words. Here you can see it a bit better. So yeah. The other part now, and well, for the live stream, the most important part, because otherwise we wouldn't have microscopy content, is the phototube. The phototube, originally named because they were using old for the time they weren't old, but they were using film cameras, which I do not have with me currently, but yeah, I have a few of them. You can be sure of that. So yeah, it was named the phototube because they were using it to take pictures of the microbes that they were observing, so they can most easily describe it later, especially because, like, imagine trying to draw, because they were used to drawing. They used to drawing stuff like this. Those are drawings, which obviously someone made them, and they had to make them especially before the phototube was invented, or before cameras weren't even introduced, because microscopes existed for, I think, a couple of centuries before the camera. Like, I'm pretty sure that the earliest use of a microscope was with Leeuwenhoek. I'm not sure about this, but in the 1750s, something like that. So it's about 150 years before, or 100 to 150 years before the invention of the camera. And I imagine that cameras started getting used pretty late for microscopy, especially for protistology, because protists move, and the first cameras weren't very good at capturing light, so they needed long exposures, like, I mean, minutes. Some of the earlier photographs have no people, or the people are so blurry because you couldn't take just a snapshot as we're used today, and that was very important for them, obviously. So yeah, and right now it's obviously very easy. Just grab your phone and point it to the objective. Obviously it's not gonna be as good as with a phototube, and I'm still using my phone, by the way, as you can. Let me turn it a bit more, because camera stuff and microscope stuff is expensive. Also, please ignore my Ajax. So yeah, right now I'm using an extension tube, which let me show you. That was maybe a bad decision. Let me unscrew it otherwise, because I'm gonna need to recalibrate. So there it is. This is the extension tube, which essentially it's a different type of objective that I have jammed up in here. This is a piece of rubber that I've used to make it hold, because gods, it was very, very unstable, especially in the beginning, and this plastic stuff, not very good, truly and really not very good. Also, I'm sorry for the loud noise of the screwing. So yeah, normally I would have loved to have my DSLR looking down the microscope, but It needs a special adapter with more optics for chromatic corrections and aberration corrections and stuff like that, which it's, well, expensive. So I'm gonna get it though. Don't get me wrong, but not right now. Also, there's the problem with my DSLR bit, which the frame rate is a bit shit. So we'll see. I may need to either change cameras, which I'm planning to buy a new one, a better one, or take a different approach to essentially the recording stuff, the recording thingy, because Canon is a bit I would say crappy at the webcam DSLR for webcam software, which is not good for me because I'm a Canon user. Like, here's my Canon 5D Mark III, a very good camera, by the way, amazing one, but not for video, definitely not for video. So yeah, well, yeah, once I fix that though, you're gonna get some treats, because I'm gonna have an actually decent frame rate. I'm not sure if that's considered a treat, but whatever, it is for me, and you're gonna have to deal with it. Well, it's your choice. So, yeah. So, now let's move on. We'll go from down up. So I'm gonna change the view a bit. You're not gonna be able to see me, but I'm not sure how bad of a, situation this is. Yeah, please focus on the right spot. Perfect. Got it. Yeah. So, let me zoom a bit more. Great, perfect. So, this is the rotating drum. As you can see, this is the 100 magnification objective, I think. Yeah, it is. And you can see the quality is not that good, but it's half decent. You need to close the diaphragm a lot in order to be able to see, but sometimes there's not enough light and, annoyances. Great annoyances, but whatever. And you rotate it and you change the magnification from 4 times magnification, which along with the 10 times objective, which I have, you can get, by the way, 25 times magnification, and you can get some Barlow lenses, which essentially double up your magnification, so you can get up to like 50 times, which most of the times is not necessary, because the eyepieces just reform the image, essentially, which means that they do not contribute to the overall resolution or sharpness of the image that the microscope produces. Most of the work is being done by the objectives, and this is very important to understand, especially if you're doing microphotography, or microphotography, because microphotography is a completely different thing. I will do it at some point, and it's very easy for me to do it because I've built a few systems, or I've gotten a few systems to work with that, and I have some fairly good lenses, but I need better lighting. I need better lighting to do that, and I do not have that yet. But in the future, I will. And you bet your ass I'm gonna do it. Despite my thing being microscopy for the live streaming. But again, you're gonna see. Also, my camera is starting to run out of battery. I have like 3 more batteries over here, so we are good, and they're all fully charged. Yeah, so let's continue. The light source. So obviously for photography, for anything with optics, anything related to optics, the key is light, and with microscopy it's essentially the same. But microscopy handles light in a fairly different way, because you have a light path which goes through a few different stuff, which other other things, other disciplines that use light words do not use that. And it's important to understand that microscopy is a bit more complicated than any other form of optics related. Well, not any other form, but if you want to see microscopic stuff, starting from like millimeters in length to micrometers, meaning 1,000th of a millimeter. Let me open another. There you go. Now you can see me also with, I hope, better frame rate. Let me see my screen, my preview. It will come up in a bit, so be patient. Yeah, so my DSLR footage is indeed lagging, and that's bad. Next stream, I promise it's gonna be fixed. Well, I promise I'm gonna try to fix it. So yeah, you can stay for that. I'm gonna have to give up my monitor though. That's gonna be bad because, or not. We'll see. We'll see. We'll see. You'll have to return and learn if you're interested at all. Whatever. Anyways, so the light source in this microscope is let me see if I can pull it out. Is an LED light. Obviously, it's a dimmable LED light. Like, I can brighten it and dim it at will, because it's important to be able to control the light that goes into the sample. Sometimes you may need some different lighting, you know. Also, you may realize that this has changed the lighting that goes into the microscope. And this light source is not only obviously as light, just a light source, but it needs to be treated, essentially. And to be treated, there's this contraption, and essentially this is a diffuser. This diffuses the light, meaning it scatters it, and it just sends it everywhere. It's not focused anymore. It's just a plane of light. It's not how shall I say it? It's not a point light. It's a much larger surface that essentially we treat it as light emitting. And that's important because the light needs to be focused. And if the light source is not big enough, which it obviously isn't, it's just a small LED, like a few millimeters in diameter, and it's like about 4 millimeters, I would say, And that's very little. That's obviously very little. And you cannot just let it be. You have to scatter it and focus it. This is not just a diffuser. This is a bit of a lens. To if you see it's curved, it's a bit difficult. Let me right here. Now you can see it better, the lens element. This obviously, if it gets dirty, it's so easy to clean up, and it's so not important. Like if it gets scratched, not much of a difference in the function of the microscope. But obviously it shouldn't be scratched for obvious reasons, because the quality drops in any case. Like you cannot deny that. Now let's get the light back up. I'm gonna change the camera. Give me a moment so I did not think this through very well, but you'll see what I mean. Because I need to show you the condenser. Now, give me a moment. I'm gonna close the microphone because it's gonna be annoying for a moment. Damn, for some reason doesn't want to work properly. No, wrong. Yep, there we go. So, now that we have a better view of what we are doing, I now have 2 copies of it. Let me close the one and open the second. So, let's continue. Now, a very important part of the light path is the condenser. The condenser plays a few roles. You can now see it better. Let me move some other stuff that shouldn't be here, guys. Also, my other camera has lagged perfectly. Okay, now it's working again. I'm starting to get a bit annoyed, but it's okay. It's gonna be okay. So, what I was saying is that this part is the condenser. This is the part where you move the I forgot the word. Fuck. Anyways, the stage. You move the stage right and left. I will show you. I will show it to you in a bit better. But for now, let's focus on the condenser. The condenser holds a few functions. The first function is to essentially refocus the light and set it exactly right so it illuminates only the part which is exactly below the objective, the objective lens. When I say objective, I mean the objective lens, because again, this is the imaging part. Like, if you can see here, there's a dot. If I move up and down the condenser, you, even with the camera being so far away, may notice, yep, that the beam of light is growing and shrinking. So, essentially, there's one optimal distance for the condenser to be from the sample, because the condenser condenses the light and focuses it so the sample is properly illuminated, so you can see as much as you can, and you can get optimum performance, because again, microscopy, photography and videography and is light, and so you have to keep track of that. You have to essentially have enough of that, and it's very important to do that, to manage that. For example, now that we're talking about light, I just added another light to my room, so to the room that I'm in and filming, so you can see better, you can see what I do better, and so my cameras aren't lagging as much because they don't have to raise the ISO. The ISO is essentially like the grain on film. The higher it goes, the more brighter the brighter the image is. It's essentially a gain, a digital gain. You take the values of light and the values of brightness, and essentially you inflate them digitally so you can get the image, and it works. But too high of an ISO means a very grainy image, and that's not desirable for many reasons. Poor image quality, for one thing, and perhaps the most important, but also editing the photos, the video is worse. Is more difficult. You get less detail besides the overall quality, worse colors and other stuff, but usually you want to have as much light as possible. That's why flashes were invented, essentially, to get like all the light you need. That was very loud, I assume, and I'm sorry about that. I'm gonna fix the audio and I'm gonna make it better. I do not promise that, but I will try to do that. You shall see more improvements as I get better at this, as I progress. Anyways, so the condenser again holds a few functions. Focusing light is one that we talked about. So you have here, let me, it's on the other side. You can see it from the main camera. Here's a knob that you turn and you raise and lower the condenser, right? So yeah, one other thing is that the condenser essentially has an integrated diaphragm. Now, what is a diaphragm? For that, I'm gonna have to get a lens. And a lens I will get, but I'm gonna have to go inside here. So you're gonna have to wait for a couple of minutes, a couple of moments, not minutes. just wait. I will bring also an old film camera, but wait. Before you start waiting, those are not microbes, but I wrote that message in good faith that I would have samples prepared for you, but I don't. We're gonna prepare them together later, once I finish the presentation. And we've got some time since then, so wait. So, I am back with, guess what? An old SLR camera. An old film SLR, in fact. Those film SLRs were very popular in their day. And this is similar to what may have been used before digital cameras to capture microbes. So, here you can see the lens. Let me try and make sure at least that you're seeing this. Yep, please camera stay focused. Anyways, now I'm gonna close the diaphragm. I need to make it non-automatic. Fuck. Damn it. I'm gonna have to take the lens off. So, to take the lens off in this camera, you just have to unscrew. It took a long time, guys. Yeah. So, by the way, SLRs had mirrors inside them that redirected light into the viewfinder, so you could see exactly what your lens saw and exactly what your film would be. Sort of, not the exposure, but at least the framing. Anyways, so we have here our old Helios 44M. It's a 58mm f2 lens, which means it lets a lot of light in, and it is a fairly zoomed portrait lens. Portrait because such focal lengths usually were used. So my camera died from battery. Let me change it and I will be back in a moment. Well, I'm still here, so you don't have to wait. But let me put that battery for charging. I feel like I'm putting the battery for adoption, but whatever. Very recently, I got like 6 new batteries, and now I have 8 or something like that, 7, and most of them are good. Let me see that. It's working properly. And now we have image again. Once more. Card cannot be accessed. Guys, sorry. I'm gonna have to again. Oh, the card is burning. The card is burning. Let me see. But even though I'm not recording, like, what the fuck? Come on, please work properly. I'm gonna have to close it and turn it back on, aren't I? Come on, please work with me. Great. Huh. It's not working as well as I had thought it would, but well, I'm gonna give it another try. Otherwise, I'm gonna change cards until this one, you know, behaves. Dear Canon, please, if you're seeing this at some point, fix your webcam utility, because it's not good. Let's see. Yep, the card cannot be accessed. Perfectly. Give me a moment to format it because I'm gonna change it. Whatever. Hopefully, my other card can deal with it a bit better. The camera is a bit warm. No, still. God damn it. You're gonna have to give me a moment because technical problems. Yep. So, still, no, whatever. Still no camera. Let me change so you can see me. So, maybe we can figure it out together. But yeah. So I am back, and I have my fucking, it's a good camera, guys, I swear. It's my 70D, and it's a good camera, but it's giving me some problems right now. I'm looking for another card that I can officially format and not care about, because like the other cards I think have photos in them which I do not want deleted, obviously. I'm gonna see this one. Yeah, this one has photos, so not changing it, not formatting it at least. This one, guys, wrong card. Let me change and look what's in it. No image, perfect. I'll format this one because I have to continue. I have two other cards somewhere, but I have no idea where they are. So yeah. Trying to do a restart to the camera so it may behave, but it hasn't overheated or something. It says card cannot be accessed, so I'm gonna format it, and hopefully that cannot format change card. Fuck. There is some problem. Now you can access it. Whatever. Guys, I think we have image in a bit. But give me a moment to reconnect the camera to my laptop so you can see me in HD, sort of. Now we have proper image. Great. Perfect. Are you gonna focus now or not? Okay, it's focusing. So I'm not sure what the problem was, but we are now good to go once more. So, where's the view I was looking for? Something has happened with my sources, so let me figure it out once more. Okay, so and hopefully, yeah, it's still going on. Perfect. Once again, complete image. Guys, I'm gonna get at some point a battery adapter because I'm not dealing with this again. Well, I'm gonna deal with this again probably, but whatever. Anyways, right now I am going to close the diaphragm of this lens, and it's not changing, but see it? There it is. There is the diaphragm. There it is. And the more I close it, the smaller the opening gets. Come on. There we go. The smaller the opening gets. And the smaller the opening gets, obviously, the less light it gets in. It lets in. So this has several effects on the image. One of them, and perhaps the most important, is that your image is less bright. But besides that, usually the more you close the diaphragm, the... Come on, why have you... The more you close the diaphragm up to a point, the sharper the image gets. The more you close the diaphragm, not only the image is sharper, but besides that, it gets more contrast. More contrast between the darkest and the brightest parts. And this contrast is important. So, let's say I move the condenser upwards, right? Which is usually a decent enough spot, which not only for one magnification, but for all of them, because remember, you have 4 lenses that you have to accommodate, and you cannot be focusing and turning the knob to adjust the condenser up and down. You know, you cannot do that, so you have to figure out how to optimize it. And optimizing it obviously means that you're gonna lose something, but it's okay. But even that loses you some contrast, and contrast is very important, as you may have noticed. Some clarity, some some sharpness. So let's now obviously the diaphragm is completely open. It lets the most amount of light, right? And I'm gonna close it, not entirely, but slowly. What is this? So you can see the changes. Let me get this image. There we go. So I am slowly closing the diaphragm. Now here, come on. We have image. From here to here, you're not noticing much difference. You know, the difference is quite small. So the phone doesn't pick on anything, but I can see a very slight change in brightness, first of all, and contrast. But let's change it a bit more and more. Obviously, now between here and here, you can see the difference. And it's quite shocking, you know. Way more contrasty. The image has way more contrast. Now, if I continue closing, right, the darkest parts get very dark, and details start coming that otherwise you wouldn't notice, you know, at least not that easily. Because it has a third effect besides brightness. and sharpness, contrast. It broadens the depth of field. What do I mean by this? Now I'm bigger and I can show you a bit better. So let's say you have a lens. This lens cannot focus everywhere. Obviously, it has to focus somewhere. And right now, obviously, let me change the view again so you can see a bit better. There we go. Here we go. Let me change to the camera view because it has the most pronounced effect. Right now, it sees me. And I am in focus. So I am sharp. My face is sharp, as it should be. But the background, you will notice, is a bit blurry. Now, there are different lenses. So, this lens has a fairly wide opening. But I have a lens with an even bigger opening. This lens that I'm using right now is a 2.8 lens, an f2.8 aperture. This one is a 50mm f1.4. So let me change the lens. You're gonna lose the image for a bit, and well, maybe not, but there we go. Right now, I am using that lens, and the setting is still at 1.4, but because the focus, the view, the field of view is so much tighter, the background is even blurrier. But wait for this. Right now, it's at 1.4. Do you notice the difference? The diaphragm is fully open, so more light is let in, right? But also, the background is blurrier. Theoretically, if you had, if that was a photo, you could zoom in and see that my eyes, which I assume that the camera is focusing on, are perfectly in focus, at least one of my eyes, but the other eye is slightly blurry. And that is because the field of view of this lens, the aperture of this lens is so wide open, so that the field of view is very, very thin. Like, you can see the distance. This is one like finger width, I guess I would call it, and this finger is not even in focus. That's how open it is. And this camera has a much smaller sensor, and that means at this distance the field of view is even larger than with this camera, you know. So this is my Canon 5D Mark III, and you know, it has a full frame sensor. It has a very large sensor. I still need to figure out this webcam thing, the reversal, you know. Like, it's just in front of me and I'm out of focus. And the closer I am, you know, the less in focus things are, you know. Now you can start noticing that my ears, they're not in focus. Like, the front of my nose is not in focus, you know. So, let's close the aperture, and now I am in focus completely. I'm in focus. Like, what? Just because I closed the aperture, and because the lens is designed to be amazing, the image quality is designed to be amazing, like in, well, most apertures, I am still in a very good quality. But let's change back the lens, because it's starting to get annoying how far I need to be so you can properly see me. Come on, there we go, and now you're gonna see me perfectly again, and my lenses can stop being dusted. Yep, perfect. Let's close the other camera and get back into microscopy officially, guys. Who'd have thought? So yeah, that's one thing. So again, let me close this one, because no, not this one. Not this one, this one. Guys, I swear I have the cameras labeled, but sometimes I cannot. My brain cannot focus at all. Anyways, brain is lagging, but besides that, let's close the diaphragm a bit more and see the effects. So, this is it. And another problem is that right now you may be able to see some, problems that are not in the sample, and they're in the lens or on the lens or somewhere inside the optical column. They are not that obvious, but sometimes like the camera picks them up, but yeah, right now, surprisingly enough, I cannot even see them, which is weird, because like the previous stream was I was so annoyed by them, and I so much need to clean this shit. But anyways, back into the explanation. Let's change again the view. I have a crappy tripod that I need to deal with. So yeah, zoom back in, and we're good to go. So let me put this bad boy, my Zenith, back to the shelf. With the cap on, which I left here. Yeah. So yeah. So one very important thing in microscopy is to be able to change the way light behaves before it enters the lens. So one very important thing is that you would be able to put filters inside, somewhere inside the optical path. For now, the filters, where would you put them? Thankfully, the manufacturers have made us a great justice, and they've put a filter holder inside. Let me somewhere I have a blue filter that I could use to showcase officially, but more clearly at least. I think I'm gonna need to search a lot to find it. Even though I remembered where it is. I have a shitload of boxes. Let's open this one. I think it's in here along with a few other stuff. Like, I am just collecting so much stuff. By the way, syringes are very useful. This is the immersion oil that I was talking about in the previous live stream. I think it's completely screwed. Like, let me open it and I'll show you. It's 4 years old. It's cedar oil, I think, and it's solidly, very solidly frozen. It needs to be thrown away because it has solidified, but I'm gonna keep it for now just to see if there is some kind of use. But the filter is there it is. So there is the blue filter. The blue filter right now is a bit defunct, I would say. Its usefulness very debatable, because the earlier light sources were not induction. What the fuck am I saying? Were essentially heating coils. I'm not sure. Well, my point is, they were the previous light bulbs, the previous type of light bulbs, not the LED ones. That, you know, we get so much use of them right now, but no, wrong thing. Let me put the filter in and you'll see what it does. It's obviously a blue filter, if you manage to see it. And right now, the image is blue. And why is it so blue? Because if your light source is orange, like a candlelight perhaps, which worked well for other for the way older microscopes, and you know, these microscopes needed light source, and what they used, what they had, like candles or lamps, I think would be more oftenly used, because lamps were a more steady and reliable source of light, and a brighter one at that, because some lamps, especially from a point onwards, would burn some oils that would burn so much brighter than just a simple candle. Also, sorry if the screen is cluttered, but you know, all the views are a bit important, so let me move this one a bit to the left. Yeah, perfect. So yeah, but the filter holder right now can be used to hold other filters, namely those filters. The most commonly used ones are oblique illumination filters, which essentially illuminate the subject from the microbes, the slide only from one side. So the other side is casting a shadow, so you can see details more clearly. That creates other problems, and the way I'm doing it right now is not as reliable, but it's good enough, and you'll see it in a moment. Let me put this away, and I'll show you. Also, oh my, we've reached like 1 hour that I've been rambling about all of these things. So yeah, let me show you. So this is the microscope view, obviously, right? Usually when you use any kind of oblique illumination, you need to have the condenser, the diaphragm fully open, so the light can come from vastly different angles, right? So the filter I'm gonna use is just a black circle that I've just marked with a black permanent marker, and it's essentially a piece of paper, but it works because it blocks light, and that's what we want. No reflections, no nothing, like no kind of scattering, no type of scattering. Let me do this. Yep, perfectly. No scattering and nothing else to impede the light from any other way. So you can see I'm putting the filter in the filter holder. It's a bit difficult because it's handmade, guys. Yeah, I am that good at cutting a circle out of light. So right now, if we slide the filter holder is essentially a slot that just turns away, right? Yeah, I think you can see it clearly. If I turn it fully, obviously no light, or very little light at least, comes through. The camera can pick it up, you know, because high ISOs again. It all comes back to light again. But if I start opening it, like right now I'm opening it slightly, you can see that some weird stuff start happening. And what is this? Right now we have a dark background with bright subject, with a bright subject, which is, well, such a different view from the previous one. Like, the previous one is this one. So this is a technique called, oh god damn it, I forgot it. My brain is frozen and I am annoyed. So yeah. Yeah, the technique is called dark field. This technique is called bright field because we have a bright background with a dark subject. Dark, well, as dark as it can be, but we have a bright background. This technique, which usually is not done like that, is done by creating let's say this is the opening, right? You just create a circle in the middle that is black, and light is cast from the edges, just the edges. And it's important because you want light from the center of the source to be blocked, and only from the sides, so it can illuminate the subject itself, but not the background. That's why you want essentially black, fully black as it can be, insert, right? But if I open it a bit more, right, you see something else starts happening. Like, this is about right. You can see it's a bit more, well, you cannot see it as well because the camera is not that good at picking it out, but between this and like this, you can see it casts essentially a shadow of the thing you're looking at, and this gives a 3D effect. Like, see, this is fully open and this is sort of closed. It gives a more like, this is oblique illumination, a sideways illumination, so the 3D effects and the texture is brought back more a bit better. Theoretically, you could do this in other ways, but that's not. We can try some techniques like that at some point. It's gonna be fun, perhaps. So yeah. So let me. Oh no. Come on. Yep. Great. Yeah. So that's the filter holder, and I think we're done with the condenser, right? I usually have it fully open with this thing inside, but I'm not sure how good this is for the condenser, for the filter holder. It's a mouthful to say. For the filter holder. So yeah, it's safer, I guess, this way, but then I have to store this somewhere so I don't lose it, because it's a pain in the ass to cut a circle so evenly. Like, it took me 4 or 5 tries before I managed to do this correctly, even with one of those circle making things. I cannot remember the name, but yeah. You're gonna have to bear with me. Even if I'm not the bear. God damn it. I did it. So yeah. Then after that is the stage. The stage right now. Let me change the view again. There we go. And now this camera can show you the stage better. So let me get this one a bit smaller. This one in the middle again. And we're good to go. So the stage is a very important part of the microscope to get right, because introductory microscopes get this very wrong. They essentially have some clamps holding the slide down. Wordn't. I cannot remember words, guys. Bear with me. I'm not gonna make that pun again, so stop asking. I can see you are already asking that. Anyways, but that's not very useful. That's very confusing, because the image inside the microscope, the image that is projected on the eyepieces is inverted. If I move, I have re-inverted it because, yeah, it's wrong. Let me turn it back around and I will show you. That is exactly how I see inside the microscope. Like, the big dark long thing, that's bad, but the part in the right is in the right for me in the image inside the eyepieces. The image that I see when I look into the microscope is exactly what you see right now on the top left corner. And it's important to remember that right now I'm moving the slide, slide to the left, to the right, sorry. But did I mess up again? Yeah, but the image moves to. I move. Oh god, I've gotten confused. Lipon. So, I move the slide to the right, but the image slides to the left, moves to the left. So, and going up and down is the same. Like I move the slide downwards, or at least towards me, but the image moves differently, moves on the opposite direction, and that's important to remember, because everything you have to invert it to look correctly. But the thing is, you cannot re-invert the image on the eyepiece, right? There's no. It's not very useful to invert it back. So what you do is you get used to the movement. Like if I move right, I know that the slide is gonna move. Is gonna roll towards the left, obviously, you know. So I do not need to know where the slide is moving to know which way it's going to move towards. And that's very important because I follow microbes that move fast, and especially at higher magnifications, like at 40 times magnification. It's gonna be really difficult, and you cannot be looking at the stage all the time to see, I'm moving towards the right, moving towards the left. And especially in the beginning, it's not intuitive in a sense that at first you look at the slide, you say, when I rotate it to the left, counterclockwise, it goes to the left. But when you look into the image, you see the opposite, and your brain is confused. But after a point, you just don't think about it. But yeah, if you don't have that mechanism though, and your fingers, your hands, because you're using your hands, and you need to use one hand to focus and another to just move the slide, and that's difficult because the clamps are strong and they need adjustment, and it's complicated. It's not a simple solution, and that's annoying, especially if you like microscopy. But if you really like it, you're gonna find a way to make that work. But the point is that having a stage with a mechanical stage, because there are gears here, and I hope you can see them a bit better. Those are the gears, right? And there's a gear inside, another gear on the inside of the stage, so you can move it with rotating those knobs. Those knobs are very, very important, and it's important that they work smoothly and they're not that stiff, so they need maintenance. The more complicated the microscope gets, the more maintenance obviously it needs. Mine is not old enough, and I've used it pretty frequently, not in the past year or so, which it's been sitting getting dust on its cover, but whatever. Lately I've been using it a lot, so I've been regaining my skills in slide movement and that's important. It's really important. So yeah, What else about the stage? So also this stage has a really nice slide holder. It can hold 2 slides, but it's annoying, and the second slide doesn't work quite well. Theoretically, also you can put like 2 samples in one slide, but you have to be careful so the cover slips are not that far to the left or to the right, because the stage doesn't move as far, especially in the right, in the left side, you know, as you can maybe see. Let me see if I can, yeah, a bit better. See where the light source is. Let me open and focus a bit so you can see a bit better. On the right side it can go pretty far, but especially if you're zoomed in, because you're looking on a very, very small area. Like you're looking at an area the size of 1 millimeter by 1 millimeter. Like that's insanely small. This is an approximation, by the way. Do not, please don't take it by with a grain of salt, or maybe a few. But I'm not sure, especially when going to 100 times magnification. Like you have to be careful. Now, another important thing is of the stage is the focusing mechanism. The focusing mechanism, you can see there are 2 knobs. This sample was about to fall off. So come on. My desk is always so cluttered that yeah, whatever. There are those. Let me change the view on this camera also. Bring it a bit down so you can see it rotating. There are 2 knobs. This one and this one. Those are 2 different knobs. Like if you turn this one, the other one turns differently. This is the coarse focus knob. The coarse focus knob just makes big movements. Like look how fast the stage moves. It moves very fast, and the focus is very, very difficult to achieve. Like I can do it, but when you go up in magnification, like you're not gonna be able to focus. Like especially at the 40 times objective, it's practically impossible. You're definitely not going to the quality of I think we just have had a drop in connection speed, but it's up again, so yeah, you're not gonna be able to focus at all, and not very easily. So you have the fine focus knob. This knob just barely moves the stage, and see how the focus changes. Let me focus. Takes way more turns to focus, but turning it like that just focuses a bit down. It moves the stage very so slightly, and like with very small movements like these, like I can do them with one hand only. Like you barely even notice, but at higher magnifications you're gonna see a difference. Like let's see, let me focus. Close the diaphragm, and let's try and change them. You know, see how small the movement has to be in order to change the focus. It needs to be very, very small and very precise, and that's another skill to learn. But when you manage to do it properly, it's really rewarding. Really, really rewarding. and you can do it naturally, and you can follow up microbes that are going up and down, left and right, very fast. Because remember, while the slide is very thin, microbes are microscopic. They're called microbes, and it's called microscopy, but you get the point. And the slide may be like about the thickness inside, the thickness of the water may be like a couple of hundred micrometers, and that's like 0.2 millimeters, 0.2 millimeters. Like, it depends on how much you squeeze, obviously, it depends on the sample, but it can be from like 1 millimeter to like 50 micrometers, 50 microns. It's very, very small. So, yeah, despite that though, you need to be able, because microbes may be like 20 micrometers across, and they're incredibly small. You cannot reliably, I found, god damn it. You cannot reliably track them, especially with the coarse focus. You just can't. You need very fine adjustments. So, I see we've gone like 1 hour and 35 minutes. That's amazing. Today we're gonna go a bit longer, and I'm gonna show you a bit better how to prepare a sample and load it up into the microscope. And yeah, I hope that's fun for you, as fun at least as it is for me, or at least half as fun as it is for me, because I'm loving this. I love talking about the things I like. I might do, well, next time we're gonna do, not next time, sometime when I've got a bit of a better setup, because right now my DSLR is lagging, obviously, and is not producing such good of a signal. It's a bit messy. Anyways, I am going to do the cleanup that I said earlier, and tear it down and show you a bit more in more detail what I'm talking about, like the condenser, the diaphragm, the light source, the objectives, and I hope that's gonna be even more fun for you than it's going to be for me, because oh god, it's gonna be so annoying. Optics are a pain in the ass. Also, I need to tune the optics, at least the 40 times magnification and the 10 times magnification lenses, because I need them to be confocal to my 4 times magnification, because right now if I zoom, it's out of focus, and so ridiculously out of focus that it's gonna be difficult. I need that, so I need it to be so when I focus, when I zoom in, it's immediately in focus, because right now look at the large movement I need to make to get it in focus. That's huge. I need to be, well, barely in focus, but even this is not in focus. Well, it's only on the sides, but still, like, look at this. It's not very good. It works, but it's not very good. So I'm gonna search up, I'm gonna do some research and perhaps tear one of these down alone and see how I can tune it, because remember, I can take this off, and that's good. But it's a bit difficult to take apart. Like, let me show you a tiny bit of it. Like, first of all, you need to take this cap off. Come on, camera, please focus. Come on. Please do me the favor. Yeah, it's not cooperating as well as I would like to, it to. Come on, focus on my hand. Come on, please. I think it's a running joke amongst the YouTubers. I would think maybe. There we go. No. Yes, thank you. I can unscrew this and take this off, but then what? I have to do other stuff. Like I have to take it apart a bit more, carefully and with a bit more reason and Anyways, so yeah. Let me screw it back on. That's a bit annoying also. No, sorry, this is my 10 times magnification that I unscrewed. This one I haven't taken apart, I think. But yeah, I'm not sure exactly how to tune them, but I'm gonna have to do that. The 40 times I've completely opened it and tried to disassemble it. It's a mess. I got it back together, but it's gonna be a pain in the ass. We're gonna do it together, hopefully. Come on, camera, why aren't you focusing? Come on. Please focus on my shirt at least. No? Do you need my face? Huh. No? Have I changed something? Finally. Yeah, it was laggy. Anyways, now if I put my hand, it's gonna focus. Great. Let's go back. Also the camera is a bit warm, so I'm gonna need a better setup, guys, because yeah, that's not working as well as I would like to. Anyways, yeah, where was I? Yes, the focus. Yeah, the focus is very important. I do not think there's anything else to be said about the focus. Like, it obviously needs to be very, very smooth. Like, because just if it's a tiny bit harder than it should be, you're not going to have a nice time, because it needs to be soft, but not that soft, because otherwise the stage can roll down. Like, if I press hard enough, it's gonna roll down, and that's bad, obviously. You do not want it to leave it and just go leave it. For example, your camera, and oh no, we have a lot of dropped frames for some reason due to network issues. I do not know why. Maybe I'm gonna turn the live streaming to a 30 FPS one, just so it's a bit easier to render. Maybe that's why my camera is lagging so much, because like I do not see that much lag, or perhaps the rendering is trying to get way more frames out of my camera, so that's why it's lagging more. I'm not sure, because without me streaming, it's not behaving that badly. I'm gonna see, guys. Yep. So I think we're done. Also something that I forgot to mention, I think, is obviously the switch. It has an on-off switch for the light, and I talked about the dimmer. Yeah, right. Dimmer. Oh. Fun times with Michael. Maybe not. We'll see. You will see. Yeah. So, how about we create a sample? I think that's why you're here, actually. If any of you are here. Joke. So, to prepare your sample, you need, again, your slides, your, let me, do this. Your objective tracker. Yep. Your slides, your cover slips, as I said, very important, your sample. Now we have two samples. I cannot remember which one because for some reason, even though I told myself I would document stuff, I did not mark them or document which sample I took which bottle I took this last sample from, you know. So yeah, I usually use contact lens case. Yep. Just hold my slide on, so it has a white background. Wrong way. That's my laptop, guys. So you can say hi to it. It's doing a lot of work that it probably shouldn't. So yeah, you need perhaps a pair of tweezers. Very important. You need one pipette. Plastic, glass, doesn't really matter. You just need some way to get a drop from your sample to the slide, and the tweezers to get some solid stuff if you haven't gotten enough, because perhaps you would like to get some filamentous algae, which can be quite difficult to obtain with the pipette, you know. So you need your samples, you need your other things, you know, and you need yourself. Since I haven't found myself yet, we're not going to create this sample. So we had another drop of the connection. Yeah. I do not know why it's so annoying right now. Anyways, again, next stream I'm streaming 30 FPS because it's gonna be better for you guys. I think it's going to be much better for you. So let's unload the previous slide so you can see a bit better what's going on. Let me go get some water and I will be back. Have a look at my stuff. Memorize them because they're gonna be in the finals. So, I am back. I took a quick snack and a sip of water, and we are back. Brilliant. So let's see how much our current samples smell. So, slide. First of all, it doesn't really matter how much like you touch the slide, but in general you do not want that many fingerprints or stuff like that on the slide, you know. And it doesn't really matter, basically. It doesn't really matter. So yeah, we have our cover slips on the ready. Let me set them over here. Now we have our two samples. I think I really can't remember which one we sampled from last time, but I am going to take the sample from this one. I am not going to record it now either, but from next time I'm going to have some better samples. I'm probably going to going sampling this weekend. Short sampling trip. So yeah, I'm gonna start documentation because from one point onwards we may be getting some really cool and interesting microbes. Because I've seen some very nice stuff. Maybe maybe I may do a presentation at some point or show you some videos, but right now everything is on my hard drive and it's quite unsorted, and that's gonna be a pain to, you know, sort through and catalog and manage to take a better care essentially of my files. So yeah, let's completely unscrew. It's going to be very stinky. When I say very stinky, I mean I shouldn't have done that. Oh shit. Next time I'm gonna have some flowers over here because I need therapy. Just for this smell, besides all my other problems. Anyways, we take just small, well, I wouldn't call this small, but you know, it will have to do. And with some very careful and deliberate movements, we press as much as we want, you know. I want to make this slide a bit thicker because I think in the previous live stream, the main problem I had with the dead rotifers, oh shit, it smells bad, guys. It smells really bad. And usually I should have some paper, but right now I don't have. So I am gonna leave the pipette on top of the slide, and I don't care of anyone else or me. Anyways, we take the slide. You may notice that I have a bit more, like, let me try, I cannot zoom anymore. A bit more sample. Let me show you without spilling any of it. Like right here. Come on, dear camera. perfect. Now you can see a bit better. Anyways, I hope it's gonna be not that much. I have those very large cover slips. Usually, the cover slips that you're going to find are square, like these ones that I have, which are so smaller. Like, see, it's like less than half of it. I love those big slides. And I'm gonna carefully place it on top, and you're gonna see it spreading, and I'm gonna press it not as hard as the previous time, and we're ready. Now the slide is ready. It's not gonna go anywhere, so I can tilt it as much as I want. So you can see the sample, our sample. So yeah, let's put it under. There we go. Let me turn the camera onto me. Zoom out. Perfect. I have the other camera, this camera set up so you can follow the movements of my hand. I don't know how necessary it is. Maybe it's better for me to just get rid of it entirely, but I don't know. It's not that cluttered, but anyways, let me show you how we get the samples over here. But let me zoom in a bit. So open this, and generally you do not want to touch your samples because they're contaminated with microbes, and microbes are not that healthy for you. Like, I think it's a bit obvious, but even if they're not directly harmful to you, they're not going to be very nice if ingested. And sometimes in here there are diseases because this is again wastewater. So we do not want to touch ourselves. Smell, that's another thing. Like, there are no viruses or airborne stuff. Just pure methane and sulfuric compounds. Oh, awful. Anyways, let's turn the camera a bit and see what we got. I'm gonna bring the microscope a bit closer to me so I can see a bit better what's going on. I need to adjust again, fix the image, focus, and I'm gonna open this, dim the light so you can see a bit better, and hopefully perfect. Now we're all set. So this is obviously detritus and dead plant and animal matter. I do not see anything alive yet, which is a bit concerning. So, I found something. Let's see what it is. Something that may or may not be interesting. Like this here, but it's nothing. So, open, brighten, well, darken, because we need to go back, change the objectives, and refocus. And we are back. I'm going to close the diaphragm a bit because I want to be able to see better what's going on. So, yeah. But no signs of life. Probably because the sample is very small and generally they need to be oxygenated, and high concentration of microbes as the previous one is generally they deplete the oxygen very quickly. So because I've taken very small samples, and well, they do not have that much water compared to microbial content, things die off easily. And yeah, I know I made the mistake of not going for another sampling before today, but I think it doesn't really matter, because like we're at the 2 hour mark and I've just loaded up the microscope. Yeah. Yeah, absolutely no signs of life. Even though usually when you leave the samples for a couple of days to sit, many things that were encysted, many microanimals or microbes that would otherwise be encysted because the conditions would be unfavorable, would come out, or they would multiply because the conditions would be better, or whatever, or the predators would die off, you know. So yeah, it's very important to understand your samples before you go and just leave them around. I found something, maybe it's important, maybe not. No, it's not. It was this could have been some kind of a microbe or a worm or something like that, but it's now dead. Right now, the only possible residents of this slide are anaerobic bacteria or anaerobic things. Well, or maybe the methane, because I haven't opened it at all. The methane and the sulfuric compounds have killed everything else. That's also possible, because if you've learned anything about the process of creating wine or other alcoholic drinks, you know, that process is basically in the wine, especially, it's stopped by just the yeast dying off from their waste products, which the most important is the alcohol, and that's very important to consider. Now, those globular things that we see here, that at least I see, you don't, because I've closed the aperture, that right now you see might have been some kind of microbe, or might have been some cyst, but right now, so far as I can understand, like everything is dead. Like I haven't even seen bacteria here, which is well, surprising. But as I said earlier, everything might have died. I think those strings that you see, those are bacteria. Yeah. If you look right in the center of the screen, see the moving things? Those are very small bacteria. Some bacteria are large, some other bacteria are very small. but those are probably bacilli, or bacillus is I'm not sure how it's on the plurative, whatever, what's multiple of them. So yeah, let me close a bit more the diaphragm so you can see better. There we go. So there are two things moving here. The first thing is the bacteria. You can see deliberate movement. Let me zoom in on the phone so you can see a bit better. There we go. So the one moving erratically on the right side of the screen, right now it has gone under. The ones moving with purpose are the bacteria. But you may notice that the rest of the particles, they are moving, they're vibrating, This is a motion called Brownian motion. Essentially, water, which is the medium that those creatures, those organisms live, is water. And that's very important to understand. Water is a liquid, and liquids at room temperature are fairly hot. What I mean fairly hot is that they are essentially room temperature is, I think, in Fahrenheit, they should be around 70, 80 degrees Fahrenheit, I think. In Celsius it's like the definition essentially is 25 degrees Celsius, but 25 degrees Celsius is like 300 degrees Kelvin. And that's important to understand because that means there's a lot of movement, like not an extreme amount of movement, but enough movement in order to be able to excite, in order to be able to excite motion onto bigger stuff like particles, like small particles. Those particles may be like 1 or 2 micrometers thick. No, they're not much thicker, they're not much longer. And they are moving through this random motion of the water because like the molecules are vibrating, but they're vibrating in patterns, they're bumping into each other, and they're creating like sort of waves that go back and forth. When they hit a solid, they bounce, and they create all this motion, this type of motion, and it's called Brownian motion. Guys, today I have some problems with my internet. I hope you're getting a better, a good enough view, a good enough image. I have to do something about that. Anyways, so yeah. That is that. Let me zoom out, see if we can find anything. And I think after that, I'm gonna call it off. Because here, right here in Greece, it's midnight. And theoretically I should be off to sleep, but not yet. I got some things to do before I turn off the lights. So yeah, but let's see what we can find. Too bright? Yep. I'm gonna close the aperture anymore because it's gonna be very crappy image quality. But yeah, let's see if we can find anything else interesting. There might be something in between all these detritus, but I am not seeing it. Like right now, I'm doing a scan of all of the big objects, objects perhaps larger than a couple of hundred of micrometers in length. So yeah, let's go towards the edges. Maybe there's something in the water itself that hasn't died off. I'm not seeing anything, sadly. Well, I found something interesting. What you may recognize as a dead rotifer or a dead copepod, perhaps, or maybe it's just a random debris that have fallen in style. I think that's it. Guys, give me one moment and I will be back. You can look at some microbes while I'm away. So, I'm back. Um, I got off the room and when I got back in, guys, the smell has permeated through the room. I need to open the window because I am going to suffocate. So, let's do a bit of a closer search. So maybe we can find something moving. And I just saw something, but it's a small ciliate. I think it's a ciliate. There it is. More light, please. Yep. There we go. I think it's a small ciliate at least. Also, please ignore all of the dirt that's on the lens. Yeah, nothing very interesting. Nothing that you can see really well, at least, so you can at least admire it. So, yeah. And the second one. Funny. Haha. I'm gonna be mad if right now things start getting on. Anyways. Start waking up. Well, because in a bit I'm really gonna have to close off the stream because it's late again. I'm gonna have to eat because I haven't eaten. I just ate a snack, so you know, there's more things moving. I'm gonna be annoyed, really annoyed. Like, come on. I think I should have prepared this a bit better, you know. But yeah, nothing very interesting. Like this sphere might have been algae, but I don't know. This one, I'm truly not sure. Truly not sure. Anyways, I think I'm going to start doing the outro, guys, because I don't think it's going much it's going anywhere from here. Yep. I see nothing. So let me there we go. Close this off. Yep. Close this off. And guys, thanks for watching once more. I hope you enjoyed this live stream. Once more, I will be live again Tuesday around the same time. Also, I'm going to upload during the weekend these two live streams on YouTube, so you can see them basically forever. And yeah, that's it for me. I am very happy to be doing this, and yeah, I hope you enjoyed it. I hope you learned about microscopes and about light a bit more. Maybe we're gonna do an optics lesson. So yeah, I would like to learn about that more myself. So yeah, it's gonna be very interesting, I think. Yeah, I thought we had the drop in the network. Anyways, so thank you very much for watching, and have a good evening. Well, evening for me at least. Morning, noon, afternoon, or whatever time of the day you are in currently, and see you I have forgotten. Brain is not braining. See you in Tuesday. Bye.